So we're working on with something today called Pascal's triangle and some crazy stuff coming up in a bit. I'll show you some of the weird stuff. You see it in class also. But Pascal's triangle here is a triangle based on, so you start off the row, we call this row 0. Here's 1, and then you have 1 and 1 underneath it. And then from here, any term after that, you look at the next term. So in row 3, here's always start with 1, and then you have 1 on the outside, as you can see, all the way down here and all the way down here. And then each other term here is the sum of the two terms above it. So 1 plus 1 is 2. Here I have 1, and 1 plus 2 is 3. 2 plus 1 is 3, and 1. And then if I go down here, for example, I have 1. 1 plus 7 is 8. 7 plus 21 is 20, or yeah, 7 plus 21 is 28. This plus this is this, all the way across. You notice that there's repetition here. Okay, so 1, 9, 1, 9, 36, 36, 84, etc., etc. And there's more cool stuff that we'll see in a second. Now, why do we care about this? It's because it helps us understand what happens when we expand binomials. Okay, so if I have something like this, x plus y squared, and I FOILed it out, x plus y times x plus y, I end up with x squared plus xy plus xy plus y squared. And then when I collect like terms, I get x squared plus 2xy plus y squared. Okay, no big deal. But let's say I want to move on to something like this, x plus y cubed. Well, I take that's x plus y squared times x plus y, right? So it's this times, so it's whatever I found x plus y is, times x plus y. So I already started this here, but let's keep going. So x times x squared is x cubed. X times 2xy is 2x squared y. Then I go this term times x, which is then going to be xy squared. Then I'll go y times all these terms here. So that's going to be x squared y plus 2x, and I have an extra y, so that's y squared. And finally, y squared times y is y cubed. So I've expanded this whole thing. So basically, I've multiplied each term here by x first, okay, kind of working backwards here, and then I multiplied, so that's this row, and then I multiplied each term here. This times this is this, this times this is this, this times this is this, okay, and there should be a plus here. And then if I collect like terms, I have only this x cubed term, okay, so that guy's gone. And then I look over here, and my next, in order, I would have, it's hard to figure out what order you want to go to, but let's say we look at this one here. I have 2x squared y. Do I have any other x squared y? Yeah, I do. I have one more here. So I have 3x squared y, so that's gone. Then my next one here is xy squared. I have 1, I have 2, I have 3. And then so that's it. And then I'm left with this y cubed. So there's a nice clean pattern to this, you might have noticed. And it goes here, there's x cubed, there's x squared y, there's xy squared, and there's y cubed. Another way to look at it is this. That's x cubed. I'm going to throw some numbers up here. That's x cubed, x squared, x to the 1. And then here, I don't see an x, but that's x to the 0. Remember that ending to the 0 is 1. So as this gets smaller, right? 3, 2, 1, 0, the y value gets bigger. So I start off with 0, y to the 0, which disappears. Y to the 1, y squared, y cubed. Ah, little pattern there. How about this? Let's throw a 1 in front and a 1 in front here. How many x cubes do I have? 1. Okay. How many x squared, y squared do I have? 3, 3, 1. Do I see that anywhere? Ah, 1, 3, 3, 1. What would happen then if I wanted to find out what x plus y to the power of 4 is? Well, I'm going to take a jump forward, and I'm going to say that my answer is going to be 1 of something plus 4 of something plus 6 of something plus 4 of something plus 1 of something. Now, what's that? So 1, 4, 6, 4, 1. And what's that something? Well, I start off with x to the full value here, 4. Y to the 0, I'm not going to write it because y to the 0 is just 1. Then I have x cubed, y to the 1, or just y, x squared, y to the 1, or sorry, y squared, 4x, make this smaller, x to the 1. I'm not going to write the 1 because we don't write 1s on powers, but I could. Y cubed, x 0, y to the 4th. And if I did expand this, that's what I would get. And that's what Pascal's triangle does for us. Okay, you get these numbers here in these rows help us expand binomials. So if I had the 10th term, I'm not going to do it now, but let's say I wanted this to the power of 10. The first term is going to be 1 x to the 10. The next term is going to be in my, if I have 10 here, it's 10 here. Okay, I want the 10th the 10th row, sorry, the 10th row. So it'll be 10 x 9 y 1 or just y. The next one is then going to be 45 x 8 y squared, blah, 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 blah. Keep going. Okay. And that's really awesome that you can use Pascal's triangle to help you do that. Now I'm going to erase all this so I can you sit here and stare at Pascal's triangle and help me in the next bit. Okay. So as I erase, I will, erasing. There we go. Let's erase this. Things get a little more difficult when x and, now that's nice with x and y, but we're not going to leave you with x and y. Things get a little more difficult when we don't have x and y, when we have things like this. So instead of a and b or x and y, I may then go with something like this, 2x plus 1. Of course we have to do something like this, all to the power of, I'm going to keep it simple, but let's say 4. Okay, so I don't want to do too much work here. So let's go to 4. So I'm in row 4. So row 4, and I'm just going to go through this whole thing and write this out. So now this is my first term. Here's my second term. So you can't ignore, and you know what, I'm going to make this more difficult. Well, that's from our note. We'll keep this. We have to the power of 6, okay, from our note. 2x plus 1 to the power of 6. So I'll do what we did in our note. So 2x plus 1 to the power of 6. So I'm down here. I'm in row 6, okay? So my first one, I'm going to have 1 of 2x to the power of 6, 1 to the power of 0. Okay, so it's going to be this to the power of 6, but it's the whole thing. This coefficient here goes in here too, so it's going to get kind of messy. Now you can keep going plus sideways. I don't mind doing it up and down like this, okay, especially for the scrap board. So I have 1 of these, then I'm going to then go with 6 of something, then I'm going to go 15, so there's 15, then 20, then 15, then 6, and then 1. Okay, so 1, 6, 15, 20, good. And I go 2x to the 5, 2x to the 4, 2x to the 3, 2x to the 2, all to the 2. Be careful with that. 2x to the 1, and 2x to the 0. And then this is all 1. And the nice thing about 1 is all these are going to disappear. I will write them out though. Then you'll notice they will disappear. 1 to the 1, 1 to the 2, 1 to the 3, 1 to the 4, 1 to the 5, and 1 to the 6. You know you've done this right when one way to check your work here, make sure that these are right, is if you add the exponents here, they add up to 6. 6 and 0 is 6, 5 and 1 is 6, 4 and 2 is 6, 3 and 3 is 6, 2 and 4 is 6, 1 and 5 is 6, 0 and 6 is 6. So now I can expand each of these. I don't know, my equal signs, I kind of give up there. So I have this, now be careful here, that's 2 to the 6, x to the 6. Okay, so it's 1 times 2 to the 6, 2, 4, 8, 16, 32, 64, x to the 6. Okay, plus 6 times, and this is, you're going to have to do this in 2 steps probably. So luckily, when I expand the 1, it kind of doesn't count because it's just 1 to the power of 1. But here it's 2 to the 5, which is 32, times x to the 5. So then I'm going to have to find out what 6 times that is, which is what, 192, I think. Not sure. Yeah, 192. So this then becomes 192 x to the 5. Okay, this here is going to be 15 times 2 to the 4, which is 16, x to the 4. And then I go 15 times 16 is what, 240? So that's 240 x to the 4. And you keep going, expanding all the way through. Okay, so a bit of a pain. It gets a little nuts. It gets worse though with negatives. Let me show you. It gets worse with fractions too. So I'm going to start you off. We can look at negatives. If this was a negative, for example, then you're going to have a negative number in here, and what's going to end up happening is your sign, don't make too much of it, but your signs will change back and forth, back and forth, back and forth. So that's Pascal's triangle. I am going to do the last question from the example because it's so horrifically ugly. I think you do need some help with that. So let me just delete all this here. Oh, I started undeleting the word. So let me just go back here. So I did it again. I'm old. And we had, as our last example, this. Y over 2 subtract y squared all to the 4. So at least the 4 is a small number. One thing you want to do, so my first term is y over 2 minus, and then my second term is y squared. So in row 4, that says I'm in row 4. So when I expand, I'm going to expand to 1, 4, 6, 4, and 1. Now, what am I going to have one of? I'm going to have one of y over 2 to the 4 times minus y squared. That's hideous, to the 0. Oh, y over 2 cubed minus y squared to the 1. Let's figure out what that is. Y over 2 squared minus y squared squared. Y over 2 to the 1 minus y squared cubed, and y over 2 to the 0 minus y squared to the 4. Let's figure out what all this cleans up to be. Okay, so my first term, and usually when we write them out in class, I might write them outside. So your answer is going to be this plus this plus this plus this. But we'll do it this way because I find it's a little easier to look at if you do it this way. And then at the end we would write it out in an expanded form like this. So okay, that's great. 1 is 1. That's kind of nice. And then I have y over 2 to the power of 4, which is y to the 4 over 2 to the 4. Okay, and what's that? 2 to the 4 is 2, 4, 8, 16. So I have this. And luckily, anything to the power of 0 is 1, so that is times 1, so that is just that. Okay, so my first term here is going to be 1y, or just y to the 4 over 16. My second term, I have 4. I have y cubed, and I'm all over 2 cubed, which is 2, 4, 8. I don't know why I'm going so slowly, talking like that. But that's that. Y cubed that. Now I have times this to the power of 1, which is this, just this, minus y squared. Now this gets, we're not done here, okay? So we got to clean this up. 4 divided by 8 is 2. And then I had y cubed times negative y squared, which gets me, remember with what happens when you multiply with exponents, 3 plus 2 is 5. I end up with this, and I jumped the gun here by putting a plus. The whole thing itself is negative. So that becomes negative 2y to the 5. That's not right. Okay, let me do that again. 4 divided by 8 is 1 over 2. So just making sure that if you're paying attention here. Okay, so let me erase this stuff here. That looks like a 7 anyway. And I'm going to go like this and put this whole thing over 2. Okay, so this cleans up to that. 3 times 2 is 2. I have a negative. That becomes a negative. 4 divided by 8 is 2. So this is ugly. Okay, this is the ugly Pascal triangle. I'll show you some neat stuff about Pascal triangle in a second, but I'm running out of time. I only have 15 minutes on these things. So that's going to be 6y squared over 2 squared, which is 4. And this is going to be negative y squared all squared. Negative y squared all squared is y to the 4, but it becomes positive. So negative y squared times negative y squared is y to the 4. That is, let's clean this up. That's 3 over 2. Y squared times y to the 4, which is y to the 6. Okay, so that's that one. This guy here now is 4y over 2, okay, because that's the power of 1. This is this cubed, so it's cubed, we'll make it negative. That's negative y to the 6. So now I have 4 over 2, so this will be negative. The whole thing is going to be negative. 4 over 2, that's a 4, that's a 2. 4 divided by 2 is negative 2, or the whole thing's negative, sorry. Then I have 1y, I have 6 y's, I have 7 y's. Almost 7 wives, which would be maybe even worse. And then this here, sorry, this here is 1, okay? Anything to the power of 0 is 1, thankfully. I'm just left with this, which is not that nice. Anyway, this is y squared to the 4, so this is going to be positive. 2 to the 4 times 4 is 8, so I end up with this. There's a nice pattern here. That's y to the 4, y to the 5, y to the 6, y to the 7, y to the 8. You will find that sometimes. Hideous, beyond belief. I don't even, now I'm in row 4, I don't even see that 1, 4, 6, 4, 1 pattern here, my final answer. It disappeared, it got swallowed up by Pascal's lunacy. Let me show you one thing before I run out of time. Look at this. 1 plus 4 plus 10 is 15. That plus that is 15. What about this? 1 plus 7 plus 8 plus 28, guess what? 36. Let's go this way. All these add up to 165. The evilness of Pascal's triangle. Pay attention in class. Some crazy stuff. Take care. Bye.